Hello and welcome to another exciting edition of Anatomy and Physiology Podcast with Mr. Zabel. In today's lesson, what we're going to be looking at is the heart. And specifically, we kind of went over the basic anatomy of the heart, but what we're going to look at today is how blood is going to circulate and flow through the different chambers of the heart. And again, when we look at this, basically on your test or quiz, basically what I can do is I can pick any location on this heart. Maybe it's the pulmonary vein, maybe it is the right ventricle, maybe it is the semilunar valve of the aorta. And again, you're going to pick these different locations, and then you're going to have to travel, have that red blood cell circulate throughout the body, again to the lungs, the tissues, through the different chambers of the heart, and you're going to eventually have to go back to the starting location. But again, that's what we're going to be looking at today, is the route of blood flow through the heart. So let's take a look at how blood is going to flow throughout the body and flow through this four-chambered heart. And again, what we're going to do, you're going to have to know the skill for your quiz and your test, but you're going to have to find a starting location and then eventually get back to that starting location. And so we're going to start off very simple. So we're going to kind of point out this large structure, which should be easy enough for you to remember. It's our superior and inferior vena cava. And again, the superior is going to carry deoxygenated blood from the upper half of our body, and the inferior is going to carry deoxygenated blood from the lower half of our body. And so the blood is going to be deoxygenated, it's going to come in contact with your vena cava, and you're going to have right here, it's going to drain into your right atrium. From the right atrium, the deoxygenated blood is going to then go through this valve. Remember, this is called our tricuspid valve. It has 3 cusps to it, and so it's going to then drain down into the right ventricle. From the right ventricle, again, it's going to squeeze, and as it squeezes and contracts, it's going to be pushed up through our pulmonary, you can kind of see it in there, our pulmonary semilunar valve. After it goes through the pulmonary semilunar valve, it goes through our pulmonary trunk, and then it's going to go out to these pulmonary arteries, okay, meaning that they're going to go away from the heart. Again, we'll talk a little more about this, but arteries go away from the heart, and they're pulmonary. That means they're going to go to the lungs. And so we're going to take this deoxygenated blood, and it's going to be pumped to our lungs, and then our lungs are going to we're going to exhale, and we're going to have that CO2 be released. And again, we've kind of talked about how that process works. And again, this is part of our pulmonary circulation. So then after that's completed, what we're going to do is we're going to breathe in a whole new batch of fresh oxygenated blood. Again, it's going to saturate our hemoglobin and our red blood cells, and we're going to carry that oxygenated blood to eventually our tissues. So in order to do that, we have to go, again, breathe in the oxygenated blood, goes to our tissues of our lungs, and then we need to bring it and circulate it to our heart, where it will then come in contact with our pulmonary veins. And so again, once it comes in contact with the pulmonary veins, it's going to come inside of our left atrium. So now we're on the left side of the heart. It's going to go from our left atrium down this valve. Again, this is our bicuspid or mitral valve. It's going to go through there, and then it'll go into the left ventricle. From the left ventricle, again, we are going to squeeze the heart, again, that ventricle. It's going to then squeeze and push the blood. Again, as we do this, we're going to increase the blood pressure. We're going to push it through, if you can see it right here, that is going to be our aortic semilunar valve. So it'll go through the aortic semilunar valve, up the ascending aorta, and then it's going to go across the aortic arch, and then it's going to go throughout the body through this systemic circulation to the body tissues that are going to need that oxygenated blood. And then again, we will then eventually have those tissues produce a waste product of CO2, and it will then have this deoxygenated blood that will have to come back and then go eventually back to our inferior and superior vena cava. And then we will go through this process once more. So let's quickly review kind of what we just went over. Again, this is kind of a drawing, a depiction of what you're going to see in terms of how blood is going to be routed through the heart and through the body. But again, basically what we did is we had blood, deoxygenated blood was entering the superior vena cava and the inferior vena cava, and it was going into our right atrium. From the right atrium, we had to go through the tricuspid valve. Again, these are one-way valves to ensure that we have blood flow going in one direction, and then it goes into the right ventricle. And then the right ventricle is going to contract as well as our left ventricle at the same time. And then once that contraction occurs, we're going to push blood. Again, we're going to increase that blood pressure. And we're going to pump that deoxygenated blood through the pulmonary semilunar valve, through the pulmonary trunk, and then it's going to go through the pulmonary arteries, going away from the heart. And then it's going to eventually go to the lungs, where you will exhale. And then you're going to inhale and take in a whole bunch of fresh oxygenated blood. And so that will circulate. Eventually, it will migrate through to the lungs, to the capillaries, and then it will eventually come through your pulmonary vein. And so the pulmonary vein, again, pulmonary means it's coming from the lungs. Veins means it's going to the heart. So we're going to go to the heart. We're going to be in the left atrium through your mitral valve or bicuspid valve, again, ensuring one-way blood flow, to the left ventricle. And again, you can notice, which we'll talk about here in a little bit, look how thick this muscle is on the left ventricle compared to your right ventricle. And so we'll talk about why that is. And then once we pump this oxygenated blood through the left ventricle, through the aortic semilunar valve, it will then go up the ascending aorta to the aortic arch, where it will then be pumped to the upper half of our body through these different arteries. So you have your carotid artery, your subclavian artery, and then your brachiocephalic artery. And then it's going to come down your descending aorta and then go to the lower half of your body. And again, it's going to go and bring oxygenated blood to those tissues that need the oxygen, and they're going to produce that waste product. And again, eventually you'll have deoxygenated blood carrying more CO2 to the inferior and superior vena cava. And then we will reroute this blood once more. And again, you will do this consistently. So if we take a look at your heart, again, your heart's going to be composed of cardiac muscle. And when we look at it, we're going to see kind of these different layers. So remember, first of all, you're going to have this serous membrane. Again, you're going to have a parietal pericardium, which is going to be the outermost layer here. Again, you have this double layer of this parietal pericardium. And then directly, like attached to the heart itself, is your visceral pericardium. And then, again, right around your visceral pericardium, you have what's called your epicardium. And again, when we look at this, we're going to kind of look at these different layers of your cardiac muscle. And so we have this big layer of your myocardium, which is kind of the major muscle group of your cardiac muscle of your heart. And then this final layer, if we go the most interior into the heart structure, you have your endocardium. And again, when we look at this, remember we talked about your left side of your ventricle having such a thick wall, and why might that be compared to your right ventricle that is very thin in terms of its muscle? Well, you got to think about where the blood is being pumped to. So when we bring our oxygenated blood, we're going to pump that oxygenated blood throughout our entire body. So we're going to have to pump it with more force so we can put that blood and have it circulate to all the different tissues in our body. Whereas if we look at the right side of our ventricle, we can see that that's only going to be pumping its blood to the lungs. And when you look at your heart in relation to your lungs, your heart's going to be right here, and you're going to have your lungs right to the side. So again, it's not going to need to pump as hard and as forcefully as it would if it were pumping it to the rest of your body. So how do we go about actually bringing oxygenated blood to the heart? And then once we pump that oxygenated blood, how we bring it to the specific tissues that need the oxygen supply. And then vice versa. How do we bring it from those tissues that are producing the waste product of CO2? How do we bring that CO2 to the heart and then eventually to the lungs? Well, there's going to be a path or kind of a network of blood vessels that are going to be carrying that oxygenated or deoxygenated blood. And the three blood vessels that I want you to know are arteries, capillaries, and veins. And you can look over here at this depiction of what they are. But again, when we look at your arteries, arteries are always going to go away from the heart. So I always think of arteries away, they all both start with the letter A. When we look at arteries, such as like your pulmonary arteries, well, it's going to be having blood that's going to be pumped away from the heart, and it's going to be pulmonary, so it means it's going to be going to the lungs. And so arteries are going to bring, like I said, that oxygenated or deoxygenated blood away from the heart. Whereas capillaries are going to be kind of this network of small blood vessels that are going to have gas exchange take place. So CO2 and oxygen gas exchange is going to take place here. And then you have the veins, which are going to always bring blood, whether it's oxygenated or deoxygenated blood, to the heart. And again, when we look at your veins, such as your pulmonary veins, well, that's going to bring blood from the lungs to the heart. Again, pulmonary is going to be specifically known for dealing with the lungs. So take a moment here, put your hand over your heart, and see if you can find a heartbeat. And then hopefully you can feel this lub-dub, 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 lub-dub. Again, what we're going to be looking at is your cardiac cycle to see how your heart actually goes in action. And we're going to look at the function of it. And so when we look at your heart, it's going to cycle between these two systems. Systole, which is going to be a contraction of your ventricle. Again, that's going to be pushing the blood to your different tissues. And then a period of dystole, where we are going to relax those ventricles and we're going to fill up the ventricle with blood. And so if you take a look down here, what you can see is during this period of dystole, we're going to have our atriums fill with blood, and that blood is going to then be pulled down, and it's going to go and fill up into our ventricles. Again, once we then contract it, again, this is your muscle that we were talking about. Again, look at the size of this muscle on our left ventricle compared to our right. But then we contract it, and this is going to be a period of systole. And when we contract it, again, we increase our blood pressure because we're putting so much force into those ventricles, again, squeezing them as hard as we can, pushing that blood through the semilunar valves, and then they go into circulation throughout the body. So whenever you go to the doctor and they look at your blood pressure, and again, they put that cuff over your arm and then they make it nice and tight and then they slowly release it, what they're measuring is your blood pressure. And so when we look at blood pressure, we're just measuring the force that the blood is exerting against the walls of your blood vessels. And so basically what they're going to do is they're going to give you two numbers. The first number is going to be your systole number, and then the second number is going to be your dystole number. Okay, so your systolic and your diastolic numbers. If we take a look at your systolic number, again, this should be a higher number. And so basically what we want to see is something around the range of 140/90. Anything greater than that is going to result in high blood pressure. But again, what's going to happen is they're going to measure, again, your systolic blood pressure. So when you have the contraction of those ventricles, again, that's going to be a high number. So again, we're going to want to be around like 140. And then they're going to measure the second one, which is going to be your dystolic number, which is going to be, again, lower than your systolic number. And so, again, that's going to be the relaxation of these ventricles. But again, when they're doing this blood pressure test, basically what they're looking at to see if you have high blood pressure is to see if you are higher than this range or maybe lower than this range. Another test that they would perform is called electrocardiogram. So again, sometimes they'll hook you up to a monitor, maybe during surgery. They'd hook you up to kind of measure your heartbeats and kind of see what is going on with your heart. When we look at an electrocardiogram, basically it's going to be an electrical recording of the events that are going to be taking place in your cardiac cycle. And so some key terminology that I want you to know are these different waves. You have your P wave, you have your QRS complex, and then you have your T wave. And again, when we look at your P wave, again, this is going to be your atrial contraction, so pushing that blood down into your ventricles. And then you get this really big spike. And so this is our QRS complex. So it goes down and then it spikes way up on the R and then comes back down on the S. Again, this is going to be your ventricular contractions. So again, this is when we are squeezing your ventricles and pushing that blood through the semilunar valves to the rest of your body. And then you have this T wave, which is going to basically repolarize the ventricle. And again, you can see that happening right here. And so again, when you are hooked up to that EKG, you keep getting this nice reading, this beep, 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 beep. And of course, what we don't want to hear is a steady beep, because then you have a flat line and then your heart is not properly working. So again, if we take a look here, this is kind of what we're looking at in terms of your EKG and how it is working. But you can see, here's your P wave. Again, you can see that here are your atrium. Again, we're pushing that blood down here. So again, you have this small peak, nothing real big and drastic here. But then we get to your QRS complex. Again, this is going to be the contraction of your ventricles down here. So again, you're going to see that you have this big spike on the R, and then it comes back down. But again, this is our really high intense contraction of the ventricles, pushing it through those semilunar valves to the rest of your body. And then again, you have your T wave, which again is going to be then the repolarization of your ventricles, so they are then going back. And again, if you take a look here, this is kind of your normal EKG reading. As you increase your heart rate, again, you would see everything would be closer. So this would be a fast heartbeat, slow heartbeat, everything would be spaced out. And then if you had something that was irregular, it would be something like this, where you kind of have these long intervals, and then it might go shorter, and then longer, and then shorter. But again, these are kind of different readings that we would see. And again, if we had a flat line, it would just be a straight line, and that would tell us that we are not having contractions. So how does our heart actually keep a pace? So if you feel it right now, you can feel it going lub-dub, 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 lub-dub. But why is it when I'm sitting here, it's not constantly going lub dub, lub dub, lub dub, lub dub? Why is it not doing that? Why is it having a specific pace? And then when I do work out, it does pick up the pace. But how does the heart actually do that? Well, the heart actually has its own conduction system. And so again, it's going to be triggered through action potentials. But again, the conduction system, I want you to know this pathway. What's going to happen is if we look at your atrium, you're going to see that we have this SA or sinoatrial node. And so this is going to be where the action potentials are going to be triggered. And again, when we look at this is going to be kind of the pacemaker for the heart. So it keeps that steady pace and that nice rhythm. From there, those action potentials are going to travel along, and they are going to join up with our avioventricular node, or the AV node. From the AV node, it's going to then travel down to the right and left bundles. Again, it's going to travel down this avioventricular septum, and then it's going to eventually come out into these conduction pathways, where then it will then stimulate a contraction. But again, it's going to consistently have this sinoatrial node, this SA node, that will be the pacemaker, and then it'll kind of pass through these different pathways until it gets to the conduction pathways, where it will then stimulate the contractions. But again, just like we've talked about with muscle contractions, this is how they're going to work so you can get this nice steady pace. And finally, the last thing that I want to talk about is looking at heart sounds, because you've all experienced this. You've gone to the doctor and they've used this instrument called the stethoscope that they've put on your heart, or else perhaps they put it on your back to kind of listen to your lungs as well. But again, this device is going to let them listen to different sounds in your body. And so specifically what we're going to look at is the heart sounds. And so when we look at your heart sounds, you hear this lub dub, lub dub, lub dub, lub dub. And when they look at that, what they're looking at and listening to is they're trying to visualize what's happening with your valves. So the lub dub sound is actually your valves opening and closing. And again, if we have something that's wrong, you might have like a leaky valve where you have lub dub, or lub dub, murmur, 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 lub dub, murmur, murmur, murmur. And so again, you can have what's called the heart murmur. But again, what they're looking for is do we have leaks in your valves, or are they closing nice and properly the way they should? Well, that concludes our lesson for today. I hope this was a helpful podcast, and until next time, remember, keep studying anatomy and physiology.